So this is a picture of the edge of the universe. That is a picture of the edge of the visible universe. We can't ever see farther than that. It's not possible. Why? Well, because there's no light coming from beyond that point. Why? Because the universe is expanding. Huh? Stay with me here. We've observed that every galaxy in the universe that isn't gravitationally bound to our galaxy is moving away from us, and doing so in a very uniform fashion. Without fail, we measure that the farther away that a galaxy is, the faster that it appears to be receding from us.
Okay.
And that's a peculiar observation. I mean, a relationship that reliably linear is consistent with and really only makes sense if the galaxies themselves aren't actually moving, but rather the space between them is in some sense growing.
What? I don't get it.
Well, here's an analogy. Imagine that the galaxies are like raisins in a ball of dough, which is rising as it bakes. From the perspective of any of the raisins, all of the others appear to move away from it, with greater speeds at greater distances. But see, the raisins, galaxies, aren't themselves moving. The thing that they're embedded in, the dough, space, is expanding. See, this pattern here is just what naturally arises with things in an expanding medium.
Okay, but how could space expand?
Well, it certainly isn't intuitive, but evidently, space itself is not just some static entity, but rather it is dynamic. You see, the crux of Einstein's general theory of relativity is that what we observe and experience as gravity is nothing more than the curvature of space, or more precisely, space-time. And this is an idea that's been tested and verified time and time again. Every prediction made by Einstein's theory has been vindicated over this last century. And one of those predictions is that if space on its largest scales is more or less uniformly filled with matter and other forms of energy, which is what our best observations indicate, then the universe as a whole can't just be static. Rather, it must be evolving over time in a state of contraction or expansion, the latter of which we've observed to be the case.
Okay, so what does space expanding have to do with this being as far as we can see?
Everything. You see, a few important things happen as a result of this cosmic expansion. Not only does all of the matter in the universe become more spread out, making the universe less dense over time, but also all of the radiation or light traveling throughout the universe loses energy as it undergoes a process known as cosmological redshift. And these changing conditions combine to result in something very significant. As the universe expands, its overall temperature goes down. The universe is getting colder because it's expanding. And with all of these things happening as time goes on, what do you think would happen if you turned the clock back? Went back in time?
It would all go backwards, reverse?
Yeah, if you were to rewind the universe, not only would everything in it become younger and therefore less evolved, but the expansion would reverse back into a contraction, right? So the universe must have been denser and denser the younger that it was, with all of the matter and radiation in it becoming more tightly packed and energetic, meaning that the universe's overall temperature must have been higher and higher. And all of these trends would just continue the farther back in time you go, until you would inevitably reach a point in the distant past where the universe would be so blazingly hot that atoms couldn't have even existed. Because at temperatures high enough, protons and electrons can't hold on to each other. So what you're left with is just a universe filled with unattached charged particles, a state of matter known as plasma. And here's the thing about plasma. Light can't move through it. Not efficiently anyway, because photons, particles of light, scatter off of charged particles. And if plasma is literally everywhere, light can't go anywhere. It's trapped, endlessly bouncing around. And if light can't travel, you can't see anything. Therefore, the universe in its earliest years must have been entirely opaque, shrouded in a thick plasma fog.
Okay, alright, dude, I'm sorry. How do we know that any of that is true?
Well, because we can see it.
What do you mean?